Okay, there are a few topics in chapter 5 that we need to go over. One of them is the triangle inequality theorem. Okay, so the triangle inequality is to show if the sides are given can form a triangle or not, and to find the range of the third side of a triangle. So let's say you had some segments or some straws. Often I did this with my classes, but they had some of the kids were putting the straws in places that you probably wouldn't want to touch them again, like their nose or their mouth or something. And I thought that wasn't a very good idea. So I kind of pitched my straws, and I didn't get around to cutting some new ones. You don't want to know. All right. So let's say you had some segments that were 8 inches, and I'm just going to pretend that's a straw. Okay. And then I had one that was 5 inches, which clearly would be shorter than 8. I'm just doing some estimates. And then I had one that was 1 inch. Could I make a triangle out of these? Well, how come? Can I get these things to make a point above here? So if I went like this, it's going to collapse when I try to make it meet that one, right? Bam. They're not going to get a triangle out of it. All right, so what if I made them add up to 8, made that one 3? I still can't make a triangle because if they're the same length, there's no way to make a peak. Do you follow what I'm saying? So if I had put these together and it only equals 8, this thing's going to still collapse down on top of itself. Okay, those aren't going to make a triangle. All right, so the point is that in any triangle, the triangle inequality theorem, you don't have this on your paper because I'm not going to make you do all 3 of these statements every time. I'm just going to have you do one of them. But the point of it is the sum of the lengths of any 2 sides must be greater than the third. So A plus B would have to be bigger than C. B plus C, those 2 lengths have to be bigger than A. And when you put together A and C, it has to give you a number bigger than what that side is, B. Therefore, you will be able to make a triangle. So the sum of the lengths of any 2 sides must be greater than the third side. So here's how you do this. Oh, and then also, if you have the measures of 2 sides, the range for the third side is found by doing the difference in the sum of the sides that you know. So if I know the measures of 2 sides are 6 and 11, then the range would be 11 minus 6 to 11 plus 6, which gives you 5 to 17. So the value of the third side would have to be between 5 and 17. It can't equal 5 and it can't equal 17 either, but it can be anything bigger than 5 or less than 17. Between there. It's got to be between there. All right, so is it possible to form a triangle with the given side lengths, and explain why not? Here's what we'll explain. First of all, you just take the 2 smaller numbers. In this case, it would be 3 and 4, and they're not always labeled in order. What you need to explain is 3 plus 4 greater than the third side, 6? Well, 3 plus 4 is 7. That is greater than 6, so the answer is yes. In number 2, take the smaller 2 sides, 6 and 9. Is 6 plus 9 greater than 15? It's not, because it equals 15. 15 is not greater than 15, so no triangle. Can't make a triangle. 8 and 8, well, 8 plus 8 is clearly bigger than 8, so this one's a yes. And 2 plus 4 is greater than 5 is true, so that's a yes. 6 is greater than 5. So you can get a triangle out of those lengths. Okay, can we get a triangle out of the lengths of 4 and 8 and 16? Well, no, because 4 plus 8 is not greater than 16. 12 is not greater than 16. And then 1.5 plus 2.5, is that bigger than 3? Sure it is. That's 4 is greater than 3, so we get a triangle. So fractions and decimals are possible for the lengths of sides of triangles. Find the range for the measure of the third side of the triangle given the measures of two sides. If you have sides that are 1 centimeter and 6, then the range needs to be 6 minus 1, 2, 6 plus 1, which is a range of between 5 and 7. Now, I'm going to show you a way to write that with an inequality symbol. The third side, x, has to be between 5 and 7. And what you do is you write an inequality with x in the middle, the smallest number on the left, the bigger number on the right, and the arrows pointing to the left. Now, if you just write the words between 5 and 7, I'm fine with that. For number 8, it'd have to be between 18 minus 12 and 18 plus 12. That's going to give me between 6 and 30. And again, you can write it as an inequality if need be. Okay, 9, oops, I stopped, must have forgot to erase here. 9, the range again is adding, and then I'm going to do 5.5 minus 1.5 and 5.5 plus 1.5, so that would be between 4 and what? 7, okay. And notice this one, 1 meter. Does anybody know how many centimeters are in a meter? Well, there's 1,000 millimeters in a meter. Centa, century, what's that stand for? 100. There are 100 centimeters in 1 meter. All right, so now I got to work on the range. I needed to make the units the same. I'm not going to do that on the final exam, but this stuff is on the final. We go 100 minus 82 and 100 plus 82, and we get the range between is that 18? 18 and 182. Now, I'm used to seeing it written 18 is less than x is less than 182. So I'm thinking if it were a standardized test, you'd need to recognize it as an inequality. All right. Now, state the three numbers. If the three numbers, this is going to be practice for you. I am not going over all of these. So I'm going to leave these for you to work on after I finish our notes. And there's some more questions about the range. Okay, so please go to 19, which I believe is on the next page. Actually, if you would, I think I'm going to go in a little different order than I did with my other class. Your packet, I'll get back to 19 because we're going to want to come back to here, has a page that says, starts with the topics for semester 1 final. Okay. This is more like a notes section right here. So I'm going to go over these right now. Could you just turn to that page, please? Because this is discussing it. There's a bunch of stuff we still haven't talked about, and we're only going to get to talk about them for a couple of days. And then we're going to start reviewing for finals next week. But if this should kind of make some sense. In a triangle, where would the longest side be compared to an angle? You see this long side right here? You see, this is an angle. An angle is the space between two sides. This angle is the biggest opening, and this is the biggest side. Does that make some sense? Okay, so the longest side and the largest angle are opposite each other. If you want to put in across from each other, that's fine. Then think about this. You see the tiniest space between the sides, this little pointy angle right here? This would be the small angle, and this would be the smallest side. Okay, this is the smallest angle. This up here was the largest angle, and this was the largest side. So the shortest side and the smallest angle are opposite each other also. And sometimes it's not so obvious, like this picture, where the small side and the small angle were pretty clear, and the biggest angle and the biggest side were pretty clear. Sometimes they're much closer together, like in here, and it's not as easy to just look at it. So we got to rely on the numbers. So in this figure, list the angles and sides in triangle PQR in order from shortest to longest. We're going to do the angles first. The smallest angle is angle P. It's 45 degrees between those little segments. So that's angle P. The next is angle R. It's in the middle. And the biggest angle is angle Q. Now, across from the smallest size angle, the 45, is the shortest side. So this would be your short side, QR. Now, you see how the name of the triangle, PQR, has 3 letters? If the littlest angle is P, then the other 2 letters are the name of the side across from it. Does that make sense? The name of the side across from that angle is the other 2 letters. So, if you have angle R and you look across from it, it's side PQ, the other 2 letters besides the R, the other 2 vertices. Angle Q across from it, this would be the largest angle, and this one's the medium. Okay, small, medium, large, just like your shirts when you go shopping. Okay, we don't have an extra small, sorry, and we don't have extra large. We just got the basic sizes, okay, SML. All right, so the largest angle was angle Q, and the largest side is PR. All right, with that in mind, list the angles and sides in order from smallest to largest. Okay, so the angles would be, well, let's do the sides first because the sides have numbers on them. So I'm going to do the sides on the lower part and the angles on the top part. So I'm going to put the sides down here. I'm going to do RS. 23.7 is the smallest number. Then would be TS. And then the biggest one is PR or RT. I don't care what order the letters are. And now to figure out the angles, RS was the smallest side, so angle T would be the smallest angle. Side TS was medium, so angle R is the medium angle. And I went small, medium, and large. And the biggest angle is angle S. Okay, we're supposed to go small, medium, large. This one gives us the angle measures. So what we do is we look for the smallest angle, and then across from it is the smallest side. So this is my small side, CD. My bigger medium side would be DE. And my largest side would be CE. And then you can tell that the other letter that's missing from the 3 points or vertices is the angle that's across from that side. So you don't even have to look. CD would be, across from it would be angle E, the littlest angle. Oh, and I didn't write the angles down first. I don't know why I didn't. Angle C would be the medium angle and angle D is the biggest. Okay, this one starts off by giving us the sides. So AB is the smallest, AC is the medium, and BC is the biggest. Angles across from the smallest side is angle C, medium angle A, B, and the biggest angle would be angle A. Is that making pretty easy, I hope? Okay, now some of them, we're going to have to find a missing angle possibly, but no missing sides. Okay, so I'll just continue. Why don't you guys help me out? Someone want to tell me the sides in order from smallest to largest for number 4? What's first? UT. Then TS or ST. I don't care which way we do it. Okay. And then SU. All right. All right, now I need the angles. Angle. You can just look at the letters. Angle S. Angle U would be in the middle. And angle T would be the biggest. All right, go ahead and do number 5. And then check it. I went with the sides first since they gave them. And then the angles. Okay, any questions about 5? Okay, what do we do to find the missing angle Y on number 6? Sterling? Okay, add these two. That's 114 and subtract it from 180. Good job. All right, that's, I don't know. That's 66. All right, now we can put them in order from small to large. Angle X is the littlest, angle Z, and then angle Y. Okay, now the sides, the shortest, YZ. The medium would be XY. This is the first time I've labeled them with S, M, and L, so I don't know. I hope that doesn't confuse anybody because they're letters, but, and the XZ is the biggest. Definitely needed that third angle to know. It's not so obvious by looking. Okay, so we're going to need to find the third angles on these. If you have a right angle and a 42, the other one should be 48. Yep. And I don't care which ones you put first, just as long as you're starting going small to large as it's said to do. I believe that kept saying small to large, right? Yeah. Okay, while you guys do 7 and 8, I'm going to get ready for what I got to show you next. Why is this thing acting weird? You're like, what am I doing? I'm making triangles. Okay, are we all ready for what I got to show you next? On the next page at the top, you see some different names of things. I want to show you some more diagrams of them. The first thing on your worksheet that it talks about is, what's the name? Is it, say, a median or what? It's median? Okay, I'm going to briefly talk to you about the medians of a triangle. A median of a triangle, just pay attention up here for a minute. It goes from a vertex to the opposite side at its midpoint. So these would be equal in length. It goes from a vertex to the opposite side at its midpoint. From a vertex to the opposite side at that side's midpoint. These are all the three medians of that particular triangle. Every triangle has three. You just have to be able to recognize one. The medians do meet in a special place. It happens to be the center of gravity, but you're not going to be responsible to know that. So, like, you could balance the triangle on its center of gravity here. It's kind of an important point. The next one on the paper, what's it say? Altitude. An altitude has to have a right angle, and it is a segment going from a vertex to a side, but it doesn't have to meet its midpoint. So let me draw you a few altitudes here. This would be an altitude of that triangle, because it's the tallness. Now, if you extend the side, sometimes these triangles have altitudes that have to be drawn on the exterior of the figure. So an altitude can go on the exterior of a figure. That would be the tallness going from that side. Oops, that's a right angle supposed to be. Okay, and I could draw the other one, but I think that maybe this is enough for you to understand. Okay, what's the next one on there? Angle bisector? Oh, perpendicular bisector. Perpendicular bisector. Okay, what a perpendicular bisector does is it goes through a midpoint of a side. Oops, don't do that, mister. Goes through the midpoint of a side at a right angle. So it cuts the side in half, but it doesn't have to go through a vertex. So we can do this. That thing is a perpendicular bisector. It cuts that side in half at a right angle. Okay, now I could draw them all over in all of the sides, but that's just an example of what it looks like. Now, you have an angle bisector next? Okay, so an angle bisector is going to be something that cuts an, oh, lovely, nice. See, it's so nice when I use my tools. They do such a better job. It cuts an angle in half. Okay, so if it cuts the angle in half, you should see marks saying that this angle is cut in half. Okay, or it might cut through this, oh, nice again. Golly, that's horrible, horrible tool. I need my tools. All right, or if it cuts, say, that angle in half, then you would see the marks over here. Or it could cut that angle in half. All right, there's also special places where they meet. Now, I'm going to say here, this thing could be a what? Altitude. Yes, it can be on the side of a triangle. Okay, it could go that way too. This thing, if I made this, would be a median. Oops, sorry, slashes. Okay. If I did another one and it went through though, and it went through at a right angle, that is a perpendicular bisector. Okay, so I'm just looking at what it might look like in a right triangle. So here's what we got to do. We're going to look at this horrible picture with all this stuff on it, and I'm going to find a median. So I got to look for a side that's cut in half. And there's multiple triangles in this picture. And it has to go from a vertex. So here's the deal. You see this side cut in half right here? This is going to its midpoint, and it's coming from a vertex. That is my median. It is QT or TQ. That is a median. All right, I'm going to use pink for my per angle bisectors. Find an angle that's bisected. Anybody see an angle bisected in that whole picture? Where is it? Right here, RU. Yep. I was looking for this angle being cut in half. RU. And that's a ray, because rays bisect angles. I'm going to do blue for perpendicular bisector. I need to look for something that cuts a side in half at a right angle. And that would be, find a right angle. It's either, is that bisecting a side, this one up here? No, so it's got to be this one. Okay, SV. And it's a line. And now I want to name an altitude. I'm going to do altitudes in yellow. Altitudes can go, they have to make a right angle, so you got to find a right angle. And it's not this thing that we just highlighted. So we have a couple, we don't have many choices. Find another right angle. Up here. So it's either WP or WR. And they're the altitudes of that right triangle up there. So which one's the answer? None of those. It's A, R, W. Okay, let's try another example. So I did altitudes in yellow. I did medians in green. I did an angle bisector in pink, didn't I? Okay. And I did the perpendicular bisector in blue. Now, you may not have all these colors, but as long as you can answer them. Angle bisector, easy. Peasy, lemon squeezy. Look for an angle that's cut in half. Right up here, we've cut angles in half all year. Ray, AD. A median. Median's got to go to the middle. And that's it. Not at a right angle. So I see a side, this side's cut in half. So the median must go through point E. Is it ED or EB? It needs to go through a vertex. So it's EB or BE. Ooh, sorry, I'll make that weird E. It can be a segment or a line. Altitude, I need a toneness. It has to have a right angle, but it doesn't have to cut a side in half. It has to come from a vertex. So it can't be ED. It has to be CG. And it's a segment. And finally, yeah, altitudes can only be segments. They cannot be lines. Okay, perpendicular bisector, that's got to be that last thing. It's the one that cuts the side in half at its midpoint. It has to have two properties. So that would be ED, and it's a line. Okay, and pass through. Okay, that's all. I'm going to let you work on the problems that we haven't gone over in the packet. If you have any questions, feel free to ask. So just practice those. And on Monday, we're going to revisit these topics again. And then we're going to start reviewing for finals on Tuesday. I think you're excited. If you have any things to retake, like you want to retake a quiz or something, I'm going to show you your quizzes from yesterday and right after I finish here. You need to get in, make sure you get some help, make sure you figure out what you need to retake so you can get your grade up as high as possible before final exams.